In this video lesson, let us understand the classification of haloalkanes and haloarenes. Now, based on hybridisation, to understand about hybridisation, you may watch my video on the separate concept done about hybridisation. Now, based on hybridisation, these haloalkanes and haloarenes are classified into sp3 hybridized carbon atom, to which the halogen under consideration is attached, and the next classification of this sp2 hybridized carbon atom. What do we mean by this? Now this categorization is based on to which particular atom, to which particular carbon atom the halogen has got attached. If the halogen has got attached to carbon atom involved in sp3 hybridization, or to the carbon atom involved in sp2 hybridization. Now let us understand each one of them in bit detail. First, let us understand regarding the classification wherein the halogen atom is attached to the sp3 hybridized carbon atom. They are again further categorized into haloalkanes, that is aryl halides, or monohalo alkanes, aryl halides or monohalo alkanes, which we have studied previously. Then allylic halides, then benzylic halides. These are the three different categorization wherein the halogen atom is attached to the carbon atom which is involved in sp3 hybridization. Now, in one of the previous videos have dealt in detail with all the categories of monohalo alkanes, which are further again divided into primary, secondary and tertiary haloalkanes. Please refer for that particular video. Now, let me just continue with allylic halides and benzylic halides. What are allylic halides? These are the halogens wherein they are not attached to sp3 hybridization, which in turn is involved in double bond. That means the halogen atom halides. What are these allylic halides? These are the organic compound or the hydrocarbons which are actually derivatives of alkenes or cycloalkenes. Alkenes or cycloalkenes means they contain double covalent bond in the molecule. They are having the presence of halogen in them, but the halogen atom is attached to the carbon atom which is saturated and it is involved in sp3 hybridization. This saturated carbon atom in turn is attached to the carbon atom which is involved in double bond. Now, let us take up an example so that this concept becomes clear. Now, look at this case. This is the halogen atom which is attached to the carbon atom, and this carbon atom has involved in sp3 hybridization, and this is a saturated carbon atom. This is in turn is attached to the carbon atom which is involved in double bond. That means the adjacent carbon atom is unsaturated, but the halogen which is attached to the carbon atom, this carbon atom is saturated. So what is the name of this compound? Let us try naming this compound. The locane should go like this. So 1, 2, 3. So for the third carbon atom, chloro is there. 3 chloro, and what do we see? Between the first and the second there is double bond, and it is a 3 carbon compound, so therefore the name is propene or prop-1-ene. This is an example of allylic halide. I repeat, what are allylic halides? They are the alkenes which contain halogens in them, wherein the halogen atom is attached to the carbon atom which is saturated, in turn is attached to the carbon atom involved in double bond. Now let us take up an example for cycloalkene also. Cycloalkene. Now this is a cycloalkene, and with that Cl is attached. Cl is the member of halogen under consideration. Now what is the name of this compound? Now look at the case. This is the location of the carbon atom. The ends or the corners of the ring is occupied by the carbon atom, and the halogen is attached to the carbon atom which is saturated, in turn is attached to the carbon atom involved in double bond. Therefore, what is the name of this compound? 1-chloro cyclohexene. 1-chloro-cyclohexene. So that's about allylic halides. Now let us discuss about benzylic halides. Let us discuss about benzylic halides in detail. Now the name is giving you an idea. They are containing an aromatic ring in their molecule. They are containing aromatic ring in their molecule. To the benzene ring, a side chain is there, and to the side chain of the benzene ring, if CH2 is present attached, then all such groups are called by the name as benzyl group. So, what is the formula for calling the compound as a benzyl group? They should satisfy this condition. C6H5CH2. If this component is present, then this group is referred by the name as benzyl group. Similarly, if C6H5 is present, then we call it by the name as phenyl group. Now between phenyl and benzyl, there is a difference of methylene group or the CH2 group. Now to such a CH2 group which is attached to the carbon chain, to the side chain of the benzene ring, if a halogen is attached, this halogen can be any member. As I have shown to you, it can be fluorine, chlorine, bromine or iodine. then they all get the name as benzylic halides. Means the halogen is attached to the carbon atom which is saturated, which is forming the side chain of the benzene ring. In turn, this carbon atom under consideration is linked to the benzene ring. Then this carbon atom has also undergone sp3 hybridisation. All such halides are referred by the name as benzylic halides. One more parallel point that you should remember is these benzylic halides are furthermore categorized into primary benzylic halides, secondary benzylic halides and tertiary benzylic halides. Now let us understand each one of them in bit detail. So the example that I have given to you here, let me just replace the X with some halogen member. Let us say bromine. Therefore, the name of this compound becomes benzyl bromide. What is the name of this compound? In short, we can call this as benzyl bromide. This becomes an example of primary benzylic halides. This benzyl bromide can also be called by the name as chloromethyl. We should write chloromethyl within the parentheses. And this is bromo. Let me just replace the halogen with bromo. It can be any member of halogen there. So bromomethyl, that includes this much, and this is attached to the benzene ring. So that side chain should be written within the parentheses, followed by the name of benzene. This becomes as bromomethyl benzene or benzyl bromide, which is an example of primary benzylic halide. Now, let us also understand about secondary benzylic halides and tertiary benzylic halides. Let me write those two cases about here. Now, there goes our benzene ring. And to the side chain of the benzene ring, now you have a carbon there and there is a halogen there, and this in turn is attached with hydrogen and on the other side with a methyl group. This structure, instead of writing C here, can also be written as benzene ring as it is, then methylic, this CH group, and then end it with a methyl, and above end it with a B. Either we write like this or we write like this, we are still talking about the same structure. Here is the presence of CH. Instead of writing CH there, we can just right away write like this. Now, this becomes an example of secondary benzylic halide. Secondary benzylic halides, where the carbon atom is attached with only one other hydrogen atom or two other carbon atoms. One carbon atom is there here as CH3, one more is present attached to the benzene ring. Therefore, this is an example of secondary benzylic halide. Let us try giving the name of this compound. Now, if we consider this much, this becomes ethyl group. Therefore, this ethyl group is also having the presence of bromine, and this becomes our first carbon atom. Therefore, we can call it as bromoethyl 1 bromoethyl and the remaining portion is benzene. This becomes an example of secondary benzylic halide. Now, let us look at the example of a tertiary benzylic halide. Tertiary benzylic halide. This carbon atom will be in turn linked with two other here and one more there with the benzene ring. That means with three other carbon atoms. The carbon atom under consideration will be linked with three other carbon atoms, or it is not having any direct connection with hydrogen, as we can see in this case, or else in this case. Now here this entire thing becomes the propyl group, and here we have the presence of halogen. Let me just pretend the same halogen as bromo. Therefore, what is the name of this compound? 1, 2, 3. This carbon atom gets the name as the second. So therefore 2-bromo. Otherwise, this is a propyl group. Propan, 2-yle. So propyl and benzene. Propyl, benzene. Propan, we are talking about this because it is present in the side chain. We need to make that. For the second carbon atom, all of these are present, and then remaining is benzene. Therefore, the name of this compound becomes 2-bromo propan 2-yle. That should be written within the parentheses, and then benzene outside. This is an example of tertiary benzylic halide. Tertiary benzylic halide. So now benzylic halide is divided into three types: primary benzylic halide, secondary benzylic halide, tertiary benzylic halide. Primary benzylic halide, the name benzyl bromide or bromomethyl benzene. That's an example. And for secondary benzylic halide, bromoethyl, 1-bromoethyl benzene. And for tertiary benzylic halide, 2-bromo propan 2-yle benzene. So therefore, we have understood that all of these carbon atoms to which the halogen atom is attached is connected with the benzene ring on one side, and it itself has undergone sp3 hybridization. Thereby we completed the classification based on sp3 hybridized carbon atom to which the halogen atom is attached. In my next video lesson, I will be covering with the classification based on the involvement of carbon atom in sp2 hybridization to which halogen atom is attached. Please do watch that video also.